In this tutorial, we're going to take a look at the smooth locomotion mechanic using the SteamVR plugin. The first thing that we need to do is to create a new action that we can map to our joystick of our controller. So we're going to do that by going under Window, SteamVR Input, and let's go ahead and create a new action. And we'll just call this Move Player. And because we want to attach it to the joystick and get the positional data from the joystick, we need to make the type of this action not a boolean but a vector2. Go ahead and hit save and generate to recompile the action manifest file. Once that's compiled, let's go ahead and click the Open Binding UI. You're going to need to make sure that you've got your VR headset connected to the computer, as it will detect what type of headset you use. Once it's opened up the binding UI, you'll see that you've got the option for the current binding, and you're going to click the Edit button. In this case, I'm using an Oculus Touch controller with the Oculus Quest. What we want to do is be able to connect the action that we just created, the Move Player, to our joystick. And so we're going to scroll down to our joystick area. Right now I have no actions added, so we'll just click the plus icon. And you can use the joystick in a number of different ways. If you kind of hover over the question marks, it kind of tells you what each of those options are. But because we want to get the positional data of the joystick, particularly for the Y position, we're going to select it to use it as a joystick. What we're going to want to do here is, you'll see there's a couple of options. There's click, touch, position. We want to be able to connect the action to the position. So we're going to go ahead and click the none. And the only options that will appear are options that are set as vector2. So right now in our project, the only option we have is the Move Player one that we just created. Make sure you click the check mark, and then we want to replace our default binding. Save. Once that's done, we can go ahead and close this window, and we can close the SteamVR input window. And that's all that we need to do, set the bindings. And now we need to go ahead and add some script. So what we want to be able to do is move the player forward when they move the joystick forward. Using best practices for smooth locomotion, it's not ideal to be able to have the player strafe, like go left or right, or have the player go backwards. So we're not going to include that movement functionality within this script. So we're going to go ahead and add the script to our player prefab that we dropped in. This is just from the SteamVR API. So we'll go ahead and add a new component. And I'm just calling the script Move Player. Once that script's added to our player prefab, let's go ahead and edit it in Visual Studio. So we need to add a couple libraries into this script for us to be able to tap into the SteamVR methods and functions. So we're just going to add a couple of lines under using. First one we'll do is using valve.vr. That's the base kind of library that you'll need to access any of the Valve SteamVR functions. We're also going to add one other one, interaction system. This will allow us to be able to tap into some of the HMD or the headset's positional information. So we're going to create a couple of public variables here. One that we're going to create, the first one will be for us to be able to determine what action we want to kind of connect with. So it'll be Steam VR. Let's scroll down this list here. We're looking for a SteamVR action vector2, and we'll just call this move value. And we're going to add a couple other ones, public float. Well, this will be the speed, or the max speed, sorry. So we're going to go ahead and add a couple of other variables here. One will be to indicate the sensitivity. So how sensitive do we want the controller movement to affect our speed? And we're going to add one more variable for a type of rigid body. And this is going to be used for us to, in a little bit later, for us to determine if there are objects in front of the player. Because right now, when we do this approach, they'll be able to go right through any objects. So by being able to tap into the rigid body that's on the head, we can do what's called a sweep and determine if there's anything in front of the player. So let's go ahead and just add that variable right now. So we don't need the start method, so we're just going to remove this start method here. And we actually need one more variable, and it's going to be a private variable. It'll be float speed, and we'll set this to 0 to start. So let's first set up by getting our movement in place, and then we'll add the script that will prevent us from colliding and going through objects here. So what we want to do is we only want, again, to have the calculations of the transformation happening if the joystick is in the forward Y position. Okay, so forward on the joystick in the Y position will be above 0. So what we're going to do is we want to add an if statement, if, and what we can do is we've got this move value action that we created a public variable for that we're going to connect in the inspector in a moment. So we can, if we want to drill down to the X or the Y position of the joystick, we can go if move value, and then to get into that X or Y, we go dot axes, and then we could type if we're looking for X or Y. In this case, we're looking for Y, and if it's greater than 0. Okay, so if we are pushing forward on the joystick, we want whatever we put inside this statement to execute, and then in this case, it will be the transformation for the player. So we're going to add a couple lines in here, and then I'll kind of explain what they are. So the first one will be determining the direction that we want the player to go in, because what we want to happen is when we push forward, we're going to have wherever direction the headset is facing, that's the direction that they're going to go forward in. So we're going to create a new vector 3. We'll call this vector 3 direction. And we're going to tap into the HMD's direction that it's facing. So to do that, we're going to go player .instance.hmd transform. And then we want to get the transformation direction. So which direction the HMD is facing. And we'll go .transform direction. And so for what we need to do here is we need to pass inside this transform direction method which direction we're going to be facing. And so in this case, we're going to create a new vector 3 within here. New vector 3. And X and Y will both be 0. And then the Z value we're going to get from the forward direction of the joystick. So we'll go move value.axes.y. Then we're going to adjust the speed that the player moves in relation to how much they're pressing forward on the joystick. So we got that speed variable. So speed we'll say is equal to the move value.axes.y times the sensitivity. So how much we want to have the forward motion be will be multiplied by that sensitivity value that we'll set in the inspector. And then we want to kind of clamp that so that we can't ever go above that max speed value. So we'll just kind of reset speed to equal, and we'll use this mathf.clamp. Sorry. And basically what this does is it will clamp the number between whatever we set as the minimum and whatever we set as the maximum. And so in this case, the minimum we want is 0. We don't want to be going backwards. And the maximum will be the max speed value. So what we'll do is we'll pass in the current value, which is speed. And then the min will be 0, and then the max will be our max speed value. And then here in the next line is where we will actually transform the position of our player based on some of these values. So we'll say transform, since this script is on the player prefab, transform.position plus equals, and plus equals is the same thing as saying equals transform.position plus, just a keyboard or a shortcut. So plus equals speed times, and because we want this to be kind of equalized and normalized, we're going to use the time.delta time. And then we need to multiply that by the direction that we want to be able to go forward in, but we're going to kind of ensure that we stay horizontal on the on the plane that we're on. We're going to add in a vector 3 dot project on plane, and then here we're going to pass in the direction value, and then vector 3 dot up. So right now, if we were to save this script and then just connect the correct action to the move value variable and set these values in the inspector, we should be able to have our player go forward as we push forward on the joystick and in the direction that we're looking. All right, so I've gone ahead and commented my code. So I'm going to go ahead and save this and hop back into Unity and just kind of walk through some of the public variables that we need to set if you haven't done so already. So in the move player script, we need to specify what action we want to connect this to. And again, it's only going to show actions that are set up as vector 2s. So in this case, there's just a few here, and here's our move player. So our max speed, we need to set that obviously above 0. So I'm going to say the max speed is 5. Actually, I'm going to say the max speed is 10. And I'm going to say the sensitivity is, we'll just say 5 for now. We may need to play with those values. We might as well, while we're here, wire up the head rigid body, as we're going to go into that next part now to prevent the player from clipping through objects. If you did try this already and you put some objects in the scene, some cubes or other primitives, you'll notice that the player currently goes right through them. So let's go ahead and wire this head rigid body up. So if you look inside the player prefab, under the follow head game object, there's this head collider. If you click on that, you can see that there's a rigid body there. So let's go ahead and connect the head collider to this head field in the move player script. All right, let's save our scene and pop back into into Visual Studio. So we now are going to add some code that will prevent this movement action from happening if they are close to an object that has a collider. So what we're going to do, and if you've had any experience with ray casting in other contexts, will be similar. It is a ray cast, but it uses the idea of a method called sweep test within the rigid body object. We'll just add the one line in here called ray cast hit, and we'll just call that variable hit. And we're going to add another if statement. Okay, so this is where we're going to go and say, we're going to say if head, that's what we call the reference to that rigid body on the head dot sweep test. And here we need to specify the direction. So if you work with raycasts previously, you notice that the raycasts start with an origin point. In this case, it starts with what direction we want to do our sweep test. So what we're going to do here is something similar to what we did down here with our direction. We're going to go and type in player instance HMD transform, and then we'll do dot transform direction. In this case, all we need to pass inside here is a vector 3 dot forward, and then we need to output our hit value. So again, familiar with raycast, we would type in out. So what are we outputting? And in this case, that hit variable we created. And then how far we want the test to be. So obviously, this is going to be how close you want to be able to get to the objects. In my kind of testing, 0.5 works, but you may want to either decrease or increase that. So what will go in here is what will happen if they are close. So in this case, we don't want them to be able to move. So we can just leave that blank, and then we'll have an else statement. And then in there, we will just copy and paste this movement code that we added and paste that inside the else. So now what's going to happen is if we get close to colliding with an object through the sweep test, the code to execute movement won't fire. If all of a sudden the sweep test returns negative, then the movement code will be able to fire. So let's go ahead and save that. Go back into Unity and give that a try and see now if you're able to collide with objects. So if you want to adjust the gap that you can have between the player and objects with colliders, you'll do so again in the script. In the sweep test here, this distance, you can hard code that, or if you want to be able to change that through the inspector, we can do that up here. We could add in a new public variable. And we could just replace that right here. And that will allow you to easily adjust the closeness that the player can get with objects in the scene. If you do decide to replace the hard-coded value for the distance in the sweep test with a variable, just make sure that you go back into the inspector and replace that with a value. Otherwise, the sweep test won't work and you'll go through objects again. So here you can see in the script move player, there's this distance variable. So I'm going to set that to 0.4. And now when you go do your test, it should work. So the last thing that we need to do is to add in a bit of a vignette or tunneling system for the smooth locomotion. A lot of research indicates that the motion sickness that's experienced through that smooth locomotion occurs through seeing that movement in the peripheral. So by using a vignette which kind of blurs or fades out the edge of the scene, it kind of reduces the impact that motion sickness will have on players. There's a really great asset that's available for free in the asset store that we're going to kind of implement within this solution. So you look in your asset store and you search for VRTP or VR Tunneling Pro. You'll find this asset. Go ahead and download that and import that into your project. Like I mentioned, it's free and it's an amazing asset. I already got that in my project. So what we're going to do is we need to apply this tunneling to the camera. So you'll open up the player prefab and take a look. You'll find your VR camera. Let's go ahead and add in a new component, and we're going to look for tunneling. There are different types of tunneling scripts available. I'm not going to go over all of them. We'll use this main one here. If you are interested in diving a little bit deeper into the possibilities that are available using this asset, they've got a really great documentation on their website with some how-tos, as well as some video tutorials of how to use the VRTP. And you can find a link in the asset store right here. I'm just going to go over just basically how to apply it within the context of the smooth locomotion tutorial, but you can definitely dive in deeper. So let's go ahead and add in our tunneling script. Now the first thing that we need to do is we need to indicate what transform or what object are we using to gauge movement. So in this case, we want to determine when the player is moving. So we're just going to drop into player prefab. I'm not going to go over all the settings, but just some of the main ones. You can adjust what color the vignette is. I usually like to go with black, but you can change that. The effect coverage, so how much of the screen will get filled in with this vignette. And then the feather rate. So the feathering is how soft of the edge is. And so I would have some feathering with that, but how much you want is partly personal preference, maybe with some user testing, determining what has the best effect on reducing motion sickness. And then we've got a couple of options for detecting motion. Because we're really applying this to the smooth locomotion, we don't need the angular velocity. The angular velocity would be applied if you want to use the vignette or the tunneling approach when they rotate, which we don't need. Linear acceleration would be detecting when there's a change in speed. We want really just the linear velocity. And then we indicate the min and the max. And to really identify what these values should be, we can use this debug option. We just roll this down and look at Motion Analyzer. When you're playing the actual experience and you're moving, you're going to turn on this Motion Analyzer and it will tell you what the max speed is here. So let's go ahead and do that. For that to work, we'll play our scene. We'll need to turn on the Motion Analyzer effect because it won't be on by default. And as I'm pushing forward on my joystick and moving, we'll see this velocity max value change. And this is what we're trying to identify what our max should be in the linear velocity detection there. Let's go ahead and give that a shot. All right, so if I take a look, it looks like my max velocity was 4.5. So I can go ahead and stop the playback here. I'll leave my min at 0. And again, that's kind of how much you want the minimum to be before it turns on. I could change that to 0.1 potentially if I didn't want it right at 0. And then change this max to 4.5. Or maybe just leave it at 4. All right, and let's go ahead and save this scene and then try that and see how the tunneling effect is applied to your motion there. Like I said, you may need to play with the effect coverage as well as the feathering effect to get the optimal experience that you're looking for. Upon completion of the tutorial, you should have a smooth locomotion mechanic in place, allowing the player to move forward using the joystick in the direction that they're looking. Implementing a vignette during the smooth locomotion to reduce the impact of the motion sickness that they may experience.